everyone, so we're in IC right now on Thursday afternoon, and we are going to look over the prelab to help you guys get ready for preparing and diluting solutions. This is going to be your lab on Friday and Monday. So let's go ahead and take a look at the lab. You're going to need the lab report right in front of you. You are also going to need probably a separate sheet of paper. Those of you at home, you can open up a Word document and type along as you listen to the vodcast. So, alright, let's begin with the format that you guys need to follow when you do your pre-lab. So Roman numeral number 1 is always the title. Hey guys, you're going to laugh at me, but there are students now that are forgetting their name on their lab because they start the document with Roman numeral number 1, which is the title of the lab. So maybe we should start this by saying, hey, you know what? Give me your name, period number, and date, and then give me the title. Alright, so, alright. The title of this lab, very simple, is Preparing and Diluting Solutions. Alright, so you already got the title, so let's just move on and go to part 2. Part 2 is your pre-lab. Alright, so let's go ahead and flip a little bit. Okay, you have 3 questions for your pre-lab. Let's do them together, okay? Numero uno. You do not need to write the question. You just need to show all of your work and give me the correct answer. So it says, calculate the number of grams of copper 2 sulfate. What's the 2 after copper mean? Is charged. Good job. So copper 2 and then sulfate is SO4. And if you look on your periodic table, cation and anion sheet, that's -2. Alright, so there's your copper 2 sulfate, CuSO4. But then it says pentahydrate. So don't forget that the hydrates are attached with that crazy stupid dot thing going on. And I know that they give you the formula, but it's always good to just kind of review. Alright? Okay, let's move on. So how many grams of this, so they want to know the mass, are required to prepare 100 milliliters of a 0.10 molar solution? Okay, and it says remember to include the 5-hydrate when determining the molecular weight, show all work, and describe how this solution will be prepared in the lab. Alright, this is a tall order. So it's molarity. Okay, you're preparing a solution. This is all the stuff that I reviewed in the PowerPoint, so it's pretty easy. Molarity, the formula is moles of solute per liter of solution. Alright, you were given molarity. You were given this value. You were given the volume. Careful, we need to convert the volume to liters. You're going to solve for moles, and then when you solve for moles, you're going to switch it and change it into mass. Alright, so let's roll. So you're going to say 0.10 is equal to x. We're going to solve for the moles on the numerator. And just convert this volume into liters. That's 3 decimal movements. 1, 2, 3. So we're going to say 0.100 liters. Alright. So just grab a calculator, check your work. This is 0.1 times 0.1. You're going to get 0.01 moles. And remember, this is a hydrated salt, so when you're calculating the molar mass of this copper sulfate, you need to also include the 5 waters. Alright, so I'm going to show my work on the molar mass. I would recommend you guys do too. So let's do this carefully, okay? So copper molar mass is 63.5. Sulfur, remember you're rounding to a tenth. This is a very common mistake. On the periodic table on sulfur, you're going to see 32.066. Alright, in my class, you are expected to round the molar mass to a tenth of a gram. So what is the molar mass of sulfur? 32.1. Alright, just making sure I show my work here. Let's see, so oxygen is 16.0 grams. That's an easy one. And then you know what I like to do for the hydrate is I go ahead and I do the whole molar mass of water because so many people have that memorized. What's the molar mass of water, everyone? You got it. So you see how you can just kind of shortcut that? Alright, now let's look at the quantities, how many we have. How many coppers do you have? Just 1, so I'm going to multiply that by 1. How many sulfurs? Just 1. How many oxygens just here, not the water, just here? 4. And then everyone, how many waters do you have? 5. There you go. So multiply these through, add it up, and let's check your work, okay? Okay, I get a total of 249.6, and I really hope I'm right. Grams per mole. Anybody can confirm? Anybody got a calculator? Oh, awesome, thank you. Alright, so 249.6 grams per mole, so we're going to come back up here to our work right here. There we go. So 1 mole is equivalent to 249.6 grams. Okay, so we're going to multiply that by 0.01. Easy. Just move the decimal, right? This is 2.496 grams. Now I'm questioning you guys real quick on the number of sig figs on this problem. So could you do a huge favor for me? The volume 100 milliliters, since you're using a volumetric flask, is actually very significant. So the volume of 100, since we're going to be using a volumetric flask, we're going to assume we've got all 3 digits here. Alright, for sig figs. How many sig figs do you guys have here? Just 2. So over here, we can do a really good job in our lab if we just use 2 sig figs. If we want to assume that the molarity has more significance, we can do that, but they didn't require that in the actual problem. Do you see how the original problem just says 0.10 molar? If they said 0.100 molar, we would have to make sure that our digital scale was extremely precise. So you're lucky. The precision in this lab is pretty easy. You only need 2 significant digits. Do you need to round this 4 up? Yes. So technically the correct answer here is you're going to add 2.5 grams of CuSO4 5-hydrate into the flask. So they want you to extend this problem and describe how you're going to make the solution. So that's the final part. Alright, do you guys remember in the vodcast how I described to do it? And in class I also refreshed you a little bit. 3rd and 4th you got a refresher, but 1st period I think I skimped on you. So let's do a quick recap. Alright, so you need some special glassware. It's called a volumetric flask. Okay, it has a skinny neck and it has an etched mark on the top. You guys are going to get a 100 milliliter volumetric flask, and it'll have an etched mark in the glassware, specifically to mark where 100 milliliters is at. Alright? So, you are going to fill the flask with a little bit of distilled water, like about halfway. So this would be step number 1. You would want to fill flask halfway with distilled water. Okay, that's step number 1. Step number 2, add 2.5 grams of the solute. What do you do at this point? Step 3, technically. What do you do at this point? No, don't add more water yet. Common mistake. What do you need to do before you add more water? Nope, don't have to measure the mass anymore. We're good. Any other guesses? The solute is solid, man. What do you need? Yeah, you gotta mix it. You gotta agitate it to dissolve the solute. So you really need to agitate, stir, do something. Agitate to dissolve the solute. And in case you miss any of this, it's also in the background information for your technique. Okay. So after it's dissolved, then what can you do? Add more distilled water until you hit the mark on the flask. And when you add more distilled H2O to the mark on the flask, when you get really close to the mark, you know what you need to switch to? A dropper. A dropper, like a little eyedropper, to get the volume precise on the line. And always make sure that when you're looking at the volume in the flask, that you're eye level and that you're looking at the meniscus. You guys know what I mean? The bottom of the bubble? Alright. Alright. So there's your general answer for question 1 prelab. And that will make a 0.10 molar. Let's go to problem 2. So calculate the number of milliliters. So this is what they want you to solve for. Calculate the number of milliliters of 0.10 molar copper 2 sulfate solution that would be needed to prepare 10 milliliters of a 0.050 molar. Do you guys see how the concentration dropped? You know what this is. This is a dilution. Do you guys remember the formula for a dilution? Right, M1V1 is equal to M2V2. Alright, so over on this side, by the way, when you use this dilution, guess what? The volume has to be in liters. You have to do liters on your volume. You must. Alright, so we have the molarity of the starting solution. It's 0.10. We have an unknown volume. We don't know how much of this we need. But we know that the second volume and second molarity, we have this. And remember, we're going to convert this to liters. That's 3 decimal moves. Okay, so this is 0.01 liters. Okay, so let's run that through. 0.05 times 0.01, divide by 0.1, 0.005, and remember this is volume, right? So what's the unit on my volume? Liters. Can we switch that back? So how many times do I move it to switch it back to milliliters? 3, that's right. 1, 2, 3. So this is 5 milliliters. And if you're wondering about the accuracy of how many sig figs we should probably be using, I would be questioning how accurate this needs to be, this volume. How precise is this volume? But then, can you guys tell me how many sig figs are here? 2. And then there's 2 up here as well. So you know what? If they want 2, you know that the volume is exactly 5. Like, I mean, you can look at your calculator. It's exactly 5. So I would be okay with you guys changing the answer to, instead of saying 5, you can say 5.0 milliliters. Final answer. So you would pull out 5 milliliters from your stock bottle. You know the flask? You made a solution in the flask. You're going to pull 5 milliliters out, stick it into a different flask, and then fill it up to 100 milliliters, or 10 milliliters. You're going to fill it up to 10 milliliters. Kind of makes sense? Yeah, you're diluting. So, all right, let's do the last question. Do we have enough time, or am I out? Ooh. Am I going to have to quick? All right, quick then. Calculate the number of milliliters of a 0.10 molar solution that must be diluted to prepare 10 milliliters of a 0.015 molar. And they are looking for milliliters, looking for volume. Okay, same problem, different math. The first molarity we have, we don't know the volume. We do have the second molarity, and we do have the second volume. Remember, convert to liters. 0.015 times 0.01 divided by 0.1. So 0.0015 liters. Convert that to milliliters, guys. How many times do I move it? 3. 1.5 milliliters. If you want to round it to 2, I would understand because of sig figs, but there's your answer. Does this make sense, everyone? What do you do after the pre-lab section? What do you do next? Hypothesis. There's not really a very clear hypothesis on this one. You're not searching or finding anything. No, there is no hypothesis. You can make a generalized statement of saying this is a technique lab. We're not searching for anything. We're not solving for anything. And then what happens after hypothesis? That's the hard part. Does it go background? Oops, background and then hypothesis. My bad. Flip them. Okay, so then the background is going to be the hard part. And then can I give you advice on the procedure? The procedure is super long. There is no way you're going to write everything that they say. Shorten, summarize, you know, give me the gist of what you guys need to do. And then keep in mind on the procedure, part A and part B, some of you guys will have a volumetric flask, but some of you will not have a volumetric flask. You will only have a beaker. So that's the difference. They tell you how to prepare the solution with a flask here in part A. In part B, they tell you how to prepare it in a beaker. All right. Yeah, no problem.